We are still on Terraform. This time around, we want to look at how we can use Terraform to create an EKS cluster. Now, to do this, we'll be looking at several things that we've not actually covered before. So this is a perfect opportunity to look at covering those other areas, okay? So let me create a file, 7, let's create 8.eks.tf. So the file name is eks.tf, okay? So this is the 8th file I have here. So what we are trying to do is to look at EKS. What is EKS? I see Elastic Kubernetes Service. So for Elastic Kubernetes Service, if we need to create it, it's just a long process, right? So firstly, you need to have a VPC, right? Dedicated VPC for the EKS, right? So in this VPC, we'll also want to have an internet gateway. We want to have, within the internet gateway, we also want to have, within the VPC, apart from the internet gateway, we want to also have a NAT gateway. The NAT gateway is Network Address Translation Gateway. That's NAT gateway. So aside the NAT gateway, we want to create subnets within the VPC, right? So we want to have subnets, we want to have route tables. After having the route tables, we want to create the EKS cluster, right? The EKS cluster is going to have its, what's it called? It's going to have the IAM row, right? And having a cluster policy attached to it. So it's just so long, right? So to do this, we want to use Terraform to provision all these resources that I've mentioned. And as we are going through, I'll be explaining what we need to know in the course of the journey. Okay, so now, the first thing we want to do is to go and check the Terraform row that we created. Let's see what we have attached to it. Remember the last time we created instances and did all of those good things, right? So, but to use that Terraform row that we created, this is the Terraform row, we attached a policy, right? And the policy we attached then was the Amazon EC2 full access. So this Amazon EC2 full access gave us the ability to create those EC2 instances. But this time around, we want to do much more. We want to create a cluster, an EKS cluster. We'll create the nodes, right? We'll create IAM roles, right? So we'll be creating so many resources. So this Amazon full access, Amazon EC2 full access will not be sufficient for us to do all of this. So for that reason, I want to attach a policy to this role, right? Which will allow us to do everything, right? So let me remove this, right? You could leave it, but I just want to remove it so we know what we are adding. Oh, what did I do? Then I'll check it. Policy, remove, delete. Okay. What's wrong? Let me refresh. Oh, I was practically out. Okay, so let's go back there. So let's remove this row, this policy. Let's remove it from the Terraform row. So removed successfully. So now I want to attach a policy, and the policy I want to attach is the administrator access. Administrator, let me just search administrator. So I should have administrator access. So this is what I'm adding. Administrator access provides full access to AWS services. Okay, so this is what I need. So I'm attaching the policy. Now, this policy has been attached to the role, okay? So since this role is already attached to my Terraform instance, so let's just check it, right? Just in case you were not in the last session and you want to see how we went about it, attaching a role to an instance, right? So we have a Terraform instance. Let's search EC2. So we have this instance running. That's the only instance I have at the moment running. So you can see I am row, Terraform row, right? So how do we attach the Terraform row? So you come here, actions, see security, modify I am row, right? You can come here and attach the I am row you want. Okay, so this is how you go about it. So we are not doing anything, we are keeping it as it is. So let's go to, let's get started. So I have the I am row set up, okay, and I have full administrative access, right? Administrator access is what I have. So now that we have that, so let's check out our file. So the first thing we want to do is to ensure that we have that access, right? So that's it. We've covered that. So let's note that here. So let me close this up. I have a full screen. Okay. So that's the first thing we did. So secondly, we want to specify the cloud provider, right? We are trying to put together our Terraform script. So we want to specify the cloud provider. So let's look at the components of that. So we'll be putting them together as a single file, right? So all the steps will be detailed. So the first step is to specify the cloud provider, which we have specified here, provider, AWS, right? And the region that I have my file set up is, let's confirm that, not Virginia, US-East-1, okay? So that's what I have. So that's the region, right? So you can see. So now Terraform, the required providers, AWS, you can see the source. So you don't need to memorize this, right? But there's need for you to understand the components of the script so that when you need to make modifications, you'll be able to make it with ease. So the next step we want to take now is to create a VPC, right? We want to create a VPC. To create a VPC, right, we need to specify the cloud provider first, which we've done. So this next step will cover VPC creation, okay? So step 2, we are creating a VPC, right? So now, in creating a VPC, remember, when we're looking at instance creation, right? We said we must specify resource that we are creating. Then here, what you have here will be AWS underscore instance, right? Which can change. So also for this resource, this VPC that we are creating, we must have this specified as it is. You can't change this, okay? However, what you can change is this. You can change this name, right? You see, you can change this. You can change this name. But I want to call it TechDom VPC, okay? So now, in terms of CIDR block, right? You want to know, depending on the number of resources you want, right? So in this case, I'm trying to maximize the resources that I'll have in my environment, right? So that's what I'm going for, this CIDR block. I want to be able to create 65K plus instances, right, within my environment anytime. So, but for us to understand how this works, so if you copy this CIDR block, the CIDR block, and you go to, let's go and check out CIDR block to IPv4. Okay, to IPv4. Okay, let's look at that. So you can look at this platform here, right? If you replace this with 16 and calculate, let's see what we get. You see, 65,536 posts will be created, can be created using the CIDR block, right? So you see, so the first IP will be this, you see. So the last IP will be this. So this is the total hosts that can be created. So let's take note of that. So that is why when you are creating a VPC, there is need for you to specify the CIDR block, right? So that is it. We specify that. This is what we want. So if we wanted less resource, we could change this part, right? Let's say we want not as much as 65,000. Let's say we want much less. We can come here and let's say we want much less. If we change this to, let's change it to 21, for example, you see, we're able to create 2,048 posts, right? So that is how we go about that. Okay, so now we've seen why it is important to specify the CIDR block when creating a VPC, right? Also recall that when we're creating VPC directly on the AWS platform, we have to specify the CIDR block. So we are specifying it here as well. So the tag that I have, right, I'm specifying just a single tag, and I'm calling the tag name, and the name I'm giving it is TechDom VPC. So you can make this what you want it to be, right? It could be Lagbaja VPC, it could be Tamedo VPC, right? But whatever you are changing it to, take note, some other things will be affected as we proceed, but I'll be calling your attention to it, okay? So this is this. So with this step, we create a VPC. Now, the next step we want to look at is having to create our internet gateway. So it is with the internet gateway that there can be communication with the outside, right? So we need to create an internet gateway, okay? We need to create an internet gateway. So that's how we create an internet gateway. So to create an internet gateway, you want to specify a resource, right? Remember, resource, and the resource is AWS underscore internet underscore gateway. This can change. It has to be exactly like this, okay? Now, what can change? We can change this. We are calling it TechDom IGW. That's TechDom Internet Gateway, right? Now, the tags TechDom Internet Gateway. But I skipped something. We need to go back there, right? Remember, we created a VPC, right? We created a VPC. Look at line 23. We created a VPC. We called it TechDom VPC, right? Remember, we said this can change, but this can change, right? Take down VPC. So your VPC ID, right, is going to be this part dot this part dot ID. Okay. So if you have changed yours from take down VPC to Lagbaja VPC, so what you will have here will be AWS underscore VPC dot Lagbaja VPC dot ID. Take note. So that is how you create an internet gateway, right? So I'll provide this on the GitHub, my GitHub repository, so you can have access to it. But at least you know, if you need to make changes and make this your own, you know what to look out for. So VPC ID is going to be this part, that's this part. You can see it's highlighted up there. See this part, dot this part, dot ID. That's VPC ID. So this is how we create our internet gateway. So let's go to step 4. So what do we want to do with step 4? With step 4, we want to create subnets, right? We want to create our subnets. We'll create our subnets and we'll create our subnets, okay? In step 4, we want to create our subnet. So let's put this here, right? So let's go to the top of step 4, okay? Step 4, we are creating our subnets. Okay, now in creating subnets, we should know that for the purpose of creating our EKS, right, we need subnets, right? We need the private subnet and the public subnet, right? So for the purpose of this, we are creating 2 each, right? We are creating 2 each. So we are creating 2 subnets, right? So we have 2 subnets, 2 private and 2 public. Okay, so let's see. The first part is the private subnet that we are creating. Right now, look at this part, right? We are creating a resource, and the resource is subnet, right? The resource is the subnet. Remember, within the VPC, we'll create subnets, right? The subnet is where you have your resources created. So some resources will need to be created in the private subnet, while others will need to be created in the public subnet. For there to be communication, right, with the outside, you need the internet gateway, right? Then we'll also need to create route tables as well to uh, ensure that there's communication within the VPC. Okay, so now that we have established this, we are trying to create subnets. So we are creating our private subnet, right? We are creating them in different availability zones. Okay, so let's see what we have. Let's go to AWS. Let's go to AWS. Let's see. Availability zones. What did I type? Availability zones. Availability zones. Let's just go to VPC. We'll make our life easy. VPC. Okay, so see our VPC, right? And see subnets. Okay, so let's say we are creating a VPC. You can see all regions, right? So those are all the regions we have. And see subnets, right? All the regions. So let's say this is where we are, right? These are the subnets I have, right? So here, for example, these are the subnets I have in this. Okay, you can see the availability zones, right? There's A, there's B, there's C, there's D, and we have them all across. So I could choose the availability zones that I want to have my subnets created in, right? So right here, I have US East 1A, right? So I'm creating a private subnet, right? AWS subnet, but I want to tag it appropriately, right? So I'm calling it private dash US dash East dash 1A, right? So I'm creating this subnet in this particular availability zone, okay? But I'm making sure I call it an appropriate name. This name could be anything, right? As we agreed, what you have here could be anything, but whatever you are putting there, let it be reasonable and um, you know that as time goes on, you need it, right? So let's just have that in mind, okay? So we are creating this. This could be anything actually, but let's look at this CIDR block, okay? This is important. But before we go into that, look at this. Remember when we created our VPC up there, we said AWS VPC dot TechDump VPC dot ID. Remember the same thing we quoted when we were creating our, what's it called, internet gateway, right? See, so the same ID. So just for you to take note, if you've changed yours to Lagbaja VPC, you must also come here and change this to Lagbaja VPC. Otherwise, there will be no connection. Let's say, for example, you can see it's highlighted this blue, yes. See, when I decide to make a mistake and spell this wrongly, do you notice something? This changed color, right? So let's restate it, take down VPC. So you can see it. So I spelled it correctly. So if I had mistakenly put Lagbaja VPC, right? You can see Lagbaja VPC. You can see there's no flow, there's no communication, right? So I want to make this what it should be. I step down VPC, okay? You can see the color has changed. Now, the CIDR block we want to put here, right? So this part is very important. It's very important we take note of this, right? You can see this is the availability zone that we are creating this private subnet in, okay? So this is the availability zone, right? So yeah, you can see what we named it here. So now, what determines our choice of this CIDR block, right? If you remember, when we were creating our VPC, we entered 10.0.0.0/16 so that we will be able to create as many as 65,000 plus hosts, right? So right now, we are looking for what will be the appropriate size for each subnet, right? How many resources can be created in each subnet? So that determines the choice of this CIDR block we've chosen. So if I copy this now, let's go back to uh, that resource we have online for converting. So let's put 19 here, for example, and let's see what we get. See, it tells us that with 19, we can have as many as 8,192 instances created in that subnet, which is huge, right? We want to have so many, as many as possible, because we are trying to use that, use this VPC and subnets to set up our elastic Kubernetes service, right? A managed Kubernetes service by AWS. Okay, so now I want you to also look at something else. Look at this last IP here. It is important, right? So what it means is that for every, so what it means is that for every batch, we can have as many as 266 instances, right? So this 10.0.31, right, actually started at 10.0, right? Look at 10.0.0.0, right? You can see this is the first IP. This is where it started. 10.0.0.0, 10.0.0.1, 10.0.0.2. Then it gets to 255, making a total of 256 IPs created, right? So after 255, this 0 changes to 1. Then we start counting again. 10.0.0, 10.0.1.0, 10.0.1.1, up until we get to 10.0.31.25. So what it means is that if you multiply 256, right, by 32, because it starts from 0 to get to 31, and this starts from 0 to get to 255, you realize that what we'll get will be this number. So let's just try it out, okay? Calculator. But don't get yourself so confused, right? Because let's say 32 times, what am I doing? 32 times 256, let's see what we get, equals 8192, right? You can see 8192. But let's not get confused, okay? So let's see, it tells us this is the starting IP. We don't want to know how it was calculated. This is the ending IP. So after this one, what I expect to see is 10.0.32.0, okay? So that is the next thing I want to see, okay? So based on this trend, okay? So we've established that. So when we want to determine the CIDR block for the next subnet, okay? So let's go back to where we're coming from. You can see this first one has been established, okay? So let's not stop at that. Let's take a look at this, okay? Let's take a look at this. So these tags, right? It is important to note that this tag, which we've created, name, we want to also be consistent with the name that we give it up here, okay? So it's the same as what we have here. So name is a tag. Now, there are other tags that we also have here, okay? And these tags are very important for discoverability, right? Because we are creating these subnets for our elastic Kubernetes service. If we're creating it for something else, these tags might not be necessary, okay? These tags that we have under here might not be necessary. But because these tags, this particular subnet, we are creating the subnet for elastic Kubernetes service. So it is important for us to know that for our subnet to be discovered by the cloud control manager, right? Within the Kubernetes cluster, there's need for it to communicate, okay? So as much as possible, for private subnets, okay, this kubernetes.io/role will need to have /internal-elb here. So you can't change this, okay? It has to be this way, okay? Then set it as equal to 1, okay? Now, because the name of the cluster I want to create, I already know the name, right? The name is going to be TechDump cluster, okay? I already know the name. That's the name of the cluster I want to create. I already know the name, okay? So yeah, the second part is also very important. Kubernetes.io/cluster/cluster name. Because I already have my cluster name in my head, right? So I call it TechDump cluster. That's what I'm going to call it, okay? And this is equal to, it's either equal to owned or shared, okay? So if you want this subnet to also work for some other reasons, right? Maybe for some other resources within the organization, not just for this Kubernetes cluster, right? You can call this shared, okay? Shared. Instead of putting owned, you can say shared. Okay, just for you to know that, okay? So let's move on. So it's going to be faster afterwards, okay? So now we are creating another private subnet, okay? So the same thing we did up here, we are going to repeat the same thing, right? Except that we have a different availability zone we are creating this in. And the naming also, we are trying to match the name, okay? So every other thing is the same. Internal ELB, except for something that is different, the CIDR block. Remember, our first CIDR block was 10.0.0.0/19, right? So you cannot use this CIDR block here again because it is going to conflict. When you use the same thing, it says, oh, it's been used. Can't use it again, right? So how can we do it? Okay, so we want to be able to create the same number of resources. So this 19 will serve that purpose, okay? If we had said, remember, let's go back to, okay, see what we have here. Look at it. This is what we had originally, right? And we said here, the first, looking at this, you can see, the first IP address that was created was this. Then more IP addresses got created after hitting the 256, right? At 255, it goes one digit up. This changes to 1, and it keeps going till it gets to another 255. Then this changes to 2, okay? You see? Then it gets to 255, then this changes to 3. Then it gets to 255 here, then this changes to 4, right? So then it gets to 255, then this changes to 0. After 255, it changes to 0, and this changes to 32, okay? So what we are going to do here is to say this will become 32, okay? So when we do 32, it starts at 0, then 1, 2, 3, 4, up to 255. Then once 255 is reached, it means 256 has been completed because it's starting from 0. Then this becomes 33. Then it keeps going in that cycle until 8,192 hosts can be created, okay? So when I click on this now, you will see that the first IP that will be created will be 10.0.32.0. Then the last one will be 10.0. something, I believe is 63 or something, I can't remember. But when we generate it, we'll see what we'll get, the 255, okay? So I click on calculate. You see, the first IP is this, then the last IP is this, okay? So it starts by, what have I done? Okay, let me close this. It starts by creating this, .0, then .1, .2.3, then it gets to .255. That way, 256 is created, then it goes, this changes to 33. It's like clockwork, right? So this is the CIDR block we are using for the next one, okay? So copy this. You see what you've copied is what we have here, right? 10.0.32.0/19, okay? So if we go back to this place, okay, so we can see how the next CIDR block will be generated, okay? So we are creating 4 subnets, right? So we've looked at 1 and we've looked at 2, okay? So we'll be creating 2 more. But before we create the 2 more, I want us to see how the CIDR blocks will be generated. You can see this last one is 10.0.63.255. So after this, it's going to be 10.0.64.0. So we just change this to 64, right? Because we want the same 8,192 to be created, we click on, we use 19 still. So once we click on this, you see, the first IP will be this, then the last will be this. So to get what the next CIDR block is going to be, so it's going to be 10.0.96.0, okay? So let's look at what we have here. Remember, we had 64, which is what we have here. Then the next one, I believe it was 96, okay? So this is how we arrive at the CIDR blocks, okay? Now, this time around, we are creating the public subnets, right? We've created 2 private subnets, this looking at what we've looked at above, right? So we are creating 2 public subnets. So remember, this can't be changed. So we are creating a public subnet in this availability zone, 1A, and we are creating another one in 1B, okay? So also, here and here, we are sticking to what we had up here, okay? And the name, you can see public this time around, and we see how we got this. And remember how we got our VPC ID, right? Remember, we've explained it earlier. So something else that is important that we need to note here, okay? For this public IP address, we want to be able to map public IP address on launch. So we set this as true, okay? So this is the only way the public is different from the private. Every other thing, the logic, everything remains the same, okay? So once we create this public subnet, okay, something else needs to change, okay? So if you remember, this part, right, we had kubernetes.io/row/internal-elb. This for the private, right? So for the public, it's going to be just ELB here, right? There's no internal, okay? So take note of that. So that's regarding the tags, okay? So this will allow the discoverability of the subnets within the cluster, okay? So now, the same way we create the public subnet, okay? So once we are done with that, we want to create the network address translation gateway. Now, we'll need to check out some resources to have a better understanding of the NAT gateway, how it functions. But before then, let's paste this here, okay? So now let's look at this, right? So first thing you should know is that for you to have the NAT gateway, right, an elastic IP address must be created, right? So for the NAT gateway, we'll be looking at using an elastic IP address, right? So this is the elastic IP address resource that we are creating, okay? So once you have the elastic IP address, we'll call it, it relates to TechDOM NAT, right? That's the network address translation, okay? TechDOM NAT. So VPC, we want to set this as true, okay? Then tags, we want to stick to this name for consistency, okay? That's the name. Now, if you look at this, we are allocating, this is the NAT gateway itself that we are creating. What we created earlier here is not the NAT gateway. What we created here is the elastic IP, right? The IP address that is fixed, that doesn't change. You know, once you restart your server, your instance, the public IP addresses will change, right? Once you start the server, once you stop and start it, the IP address, public IP address changes. What if you don't want it to change? You want to have an elastic IP, right? You want to have an elastic IP. So now, once we have this elastic IP address created using this file, right? So the next thing that wants to happen is that we want to create the NAT gateway itself. So the NAT gateway must be associated with an elastic IP, right? And for us to get the allocation ID, what do? We say this dot this, right? Remember, the technique is the same, right? This dot ID. You can see AWS underscore EIP dot techdomnat dot ID. This way, you've been able to bring what you have here into this place, okay? So you've allocated, right? So now, what's the subnet ID? We now need to also link it to a particular, what's it called? Public IP address, okay? We want to link it to a particular public IP address. You know, we have two public IP addresses, two subnets, right? I mean, subnets, a particular public subnet, right? We created two subnets. So all you need is just to associate it with one subnet, right? And we pick the subnet ID as the one here. So it could have been, we could have chosen 1B. So either works, okay? So we've chosen 1A in this instance. So we are also calling this techdomnat. That's fine. So now this NAT gateway depends on what? It depends on the creation of the internet gateway. You remember we created an internet gateway up here, right? We created an internet gateway on step 3. So, and the internet gateway ID is going to be AWS underscore internet gateway dot techdom IGW dot ID. Okay. So it is the same logic. So just take note of that. Okay. Same logic every time. Okay. You can see. So to get the subnet ID, remember we got it. AWS underscore subnet dot public, that's the name, dot ID, the particular subnet we choose, okay? So also, the internet gateway, we need to enter this correctly, okay? Otherwise, unlike the other time when if we make a mistake here, it doesn't tell us that there's a mistake, right? So when we try to run it, we realize that, oh, it's failing, right? But it will point our direct attention to where it's failing. But so we want to make sure we don't make a mistake. We specify it correctly. AWS underscore internet underscore gateway dot techdom IGW. That's what it depends on, right? For this to work. So let's just read this resource to get a better understanding of the NAT gateway. Okay. So that way we'll see why we are doing what we've done. Okay. So let's paste this here. So NAT gateways, right? Instances in private subnets can connect to the internet through the public NAT gateway. but cannot receive unsolicited inbound connections from the internet. You can create a public NAT gateway in a public subnet, right? Remember, we chose a public subnet that's US-East-1A, right? And must associate an elastic IP address. Because we must associate an elastic IP address, that was why we created an elastic IP address first and named it TechDomNAT, right? Because it's for that particular, because we created it for that particular network address translation gateway, okay? With the NAT gateway at creation. You route traffic from NAT gateway to the internet gateway. Remember, we said depends on, okay? You see, because we need to route the traffic to the internet gateway for the VPC. Okay, so now that we've established this, let's go back to business, okay? So we are back at business. So what else do we need to do, right? Let's look at the next step. We want to create route tables, right? We want to create our route tables, and we need to associate the route tables, okay? The same way we do when we're using the AWS platform. So similar stuff are what we are going to do here, right? So you'll have access to all of this. So you can, but it's important to understand what we are doing and why we are doing it. So that's why I'm going into details to explain some of these things, okay? So the resource we want to create now, we'll need to create, remember we have two subnets, right? We have two subnets, right? And we have two subnets. We have two private subnets and we have two public subnets within the VPC, right? So we want to also create route tables. So this time around, we are creating just two route tables. We are creating a private route table and we are also creating a public route table. Okay, so the private route table is what we are creating first, right? So it could be either way, but this is what we are doing first. So you can see the resource that we are creating, this can change always. Whatever it is, it can change. You just have to know what this is, okay? So AWS underscore route underscore table. So, but this time around, we are creating private, okay? So private route table is what we are creating. So VPC ID, remember our VPC, because the route table, we need to work on a VPC, right? So we need to specify the VPC ID, right? Remember the way we got our VPC ID, AWS underscore VPC dot, the name we provided, TechDomp VPC dot ID. If we make a mistake here, you see, this changes color. It means there's a problem. So we need to fix it. Okay? So now, once we have that, we also need to establish these definitions here. Okay? So CIDR block here, because it is route table, so we specify 0.0.0.0/0, meaning from anywhere, okay? So we need to also specify the NAT gateway ID. Remember, when we're looking at NAT gateway, we talked about communication from the private subnet with the outside, right, through the internet gateway without any unsolicited internal communication, right, from the outside. So you see, so that's why we need to specify the NAT gateway. So if you remember, how did we get this ID? So this part is the part that doesn't change, and this is what we created, and This is the ID. So the logic is the same every time. You can see here's the NAT gateway when we created NAT gateway. Where is it? That should be step 5. Step 5, remember? Not that. AWS underscore NAT gateway underscore NAT underscore gateway dot techdomnat dot ID. Okay, remember? So that is how we arrived at what we have here. Okay, so tags, we want to call it, oh, since this is private route table, we want to call it private, okay, which is consistent to what we have up here, consistent with that. Okay, so now we also want to create the public route table, okay? Can see resource. This part doesn't change. We want to call this public, right? The VPC ID, remember, we've used this over and over and over again. So CIDR block from anywhere, okay? This string. So remember, this time around, we are not using NAT gateway. For public route tables, we'll need to connect it to the internet gateway directly, okay? So that there will be communication with the outside world, okay? So we want to use the AWS underscore internet underscore gateway dot techdom igw dot id, right? The same concept, right? Which we've gone over and over again on, okay? So now we need to associate these resources, right? We want to associate the route table. So the resource for that is route table association. You just have to know this, okay? You just have to know this. It doesn't change. So when you copy, you can decide to change this. But this time around, we are not changing it because we are trying to associate this resource with the private, this resource association is relating to the private subnet, okay? This private subnet. So for this private subnet, we want to specify the subnet ID. Remember, we created a subnet, right, for private. So this particular string relates to the private subnet that we created for US East, right? So this is the private subnet, okay, that we are associating it with, okay? So the route table we are associating it with is the route table for private, which we have up there, AWS underscore route table. So the concept is the same. This part is the part that doesn't change. This part is the part that you could change, right? So if you have changed it up there to probably private, maybe you decide to call yours private route table. So this will be private route table, right? So since I didn't call it private route table up there, if I decide to now say private route table, you can see, tells me there's a problem. This has changed color, okay? So I take this out, okay? So everything is fine now. So the same way, we want to associate the subnets 1B, right? With the private subnet as well, so private route table, you can see. Then you now associate subnet, public subnet 1A with the public route table. Then you also do the same with this, okay? With this one, subnet 1B, you want to associate it with the public route table as well, okay? So once you are done with all these associations, so we want to look at what next? What is the next step we need to take? The next step is now the big step. We've created VPC, created IGW, we've created route table, we've created NAT gateway, created all of these resources. Now to the main business, okay? The main business that I want to do now is to create an EKS cluster, okay? I remember at the beginning, I told you I already know the name I want to give my EKS cluster, and that's TechDom cluster, right? So, and I've used it up there when I was trying to figure out discoverability of the subnets, okay? So the next thing I want to look at is, let's look at step 7. Let me just copy this from my notes. Step 7, okay? So step 7, okay, so we have step 7 there. So step 7, before I can create a cluster, right, there are some steps that also need to be taken, okay? There are some steps that need to be taken. So to create a cluster, firstly, I need to be able to create IAM role for the cluster. Then attach a certain policy to that role for it to work, then create the cluster, okay? Now, the IAM role that I want to create, right, I'm calling it, look at this. If I'm creating an IAM role, right, so you must specify resource. Resource is AWS_IAM_role, okay? So this name could be anything you want to call it, right? But I'm calling it TechDOM cluster role, right? Because this is the role I'm creating, the IAM role. So I'm consistent with the name, TechDOM cluster role, okay? So this assume policy, right? This is a policy you just need to adopt to assume the role, okay? The cluster role, the cluster role that we created, right? So this is the assume policy script that needs to be included, okay? So now, after that, we want to associate a certain policy, right, to the role that we created. And that policy is the Amazon cluster policy, okay? So we want to associate this policy, right? This policy, I decided to name it TechDOM cluster role dash the policy, right? I could have just called it Amazon cluster policy. But if I do that, I'll note that anywhere I want to use this, right? For example, if I decide to take this out, right? So if I just call it Amazon EKS cluster policy, right? I'll see that some other places, right? Like this place where I say this is dependent on this, I need to come and change this here as well. Otherwise, it won't work, okay? So wherever it is needed, you must change accordingly, okay? So whatever you do, you must know that there's an effect for every action, okay? So just make sure you fix it right everywhere, okay? So now, how do we know policy ARN, okay? So to get policy ARN, let's look at this policy. You can see policy ARN that we have here, this long string, starting from here up to here. So there's a way you can get policy ARN. Aside that, if you're able to know the full name, right, the correct policy name, this is usually the same. Then just a slash policy name. But for you to get the ARN policy ARN, so let me show you where you get it on AWS, okay? So if you come to AWS, let's say we are searching for IAM, and IAM, okay? So remember, policies, right? If you click on policy, let's clear this out. Let's put the policy here that I copied. That's the Amazon EKS cluster policy, for example. If I search for this and click on this, at the top, right? Once I click on that, at the top, you see policy ARN, okay? So this is the policy ARN that we're looking at in here. So that's how to get policy ARN, okay? So policy ARN. So this is where I will get it. So now for the role, remember, we created a role up there, AWS_IAM_role. This is the part that doesn't change. And this is the name that we gave it .name, okay? So when you have just role, right? So you see, when you have just role, you put dot name, okay? So that's that. So that's how we arrived at this. So now, creating the resource itself, the cluster. So this is the resource name. This is what you must specify. AWS underscore EKS underscore cluster. So this is the name, right? The name that I knew from beginning. TechDOM cluster. Okay. So if it were Lagbaja cluster I had up there, so this has to be Lagbaja cluster. Otherwise, there will be problem. Okay. So now the name, I'm consistent, TechDOM cluster to avoid confusion. Okay. So role ARN, remember the role ARN, because remember this one is just role, right? We have all of this dot name because it's just role. But because here it's role underscore ARN, so we'll have this part that doesn't change, dot the name we provided, dot ARN. Okay. So now we need to specify all the subnets that we created, their IDs, right? So we want to put the subnet IDs, I want to put them here, all the 4 subnets, the 2 private and the 2 public subnets that we created. You can see AWS underscore subnet dot private dot ID, right? Dot private dot ID, dot public dot ID, dot public dot ID. So now this, all of this that we've created depends on a policy, right? So this policy has to be attached for all of this to be able to get created. So it depends on, to specify that, okay? So now, so the next thing we want to do is that we want to create IAM role for worker nodes, attach the required policies, and create worker nodes, okay? So that's the next step we want to take now. So the next step, okay, so that's the next step we want to create, okay? So the next step. So I want to put this here. So that's step what? Let's see. What step is that? So that's step 8, okay? So we have step 8 here. So we are creating IAM row, right? So this time I'll call this TechDOM node row. This is the part that doesn't change. So TechDOM nodes, okay? So call this TechDOM nodes. So this is assume policy, assume row policy, okay? So the same way we attach policy 1, we attach policy 2, this is the second policy we are attaching, right? Then we attach policy 3. Now, this row we are specifying here is not the TechDOM cluster row, but TechDOM node row, right? Because these policies that we are attaching, they relate to this node that we just created, right? So we are attaching these policies to this TechDOM node row, not the TechDOM cluster row that we had up there, okay? So these ones are required for the nodes to work, okay? So you can see, now this is where we now create the resource, okay? Which is the TechDOM nodes, okay? So this is the TechDOM nodes, that's a node group that we are creating, okay? So we are creating them in and specifying these subnet IDs, right? Because these are the TechDOM nodes, okay? So we specify the subnets, okay, that we want them created in, okay? So instance type, I'm specifying t2.micro. So the requirements will differ depending on the resource. utilization required by the organization. But since this is just a practice since this is just for practice purpose, I'll stick to T2 micro. Okay, so let's look at scaling configuration. This is very important. So the desired could be 2. This is what I want at every point in time, right? But if there's need for me to scale up, I don't want to go beyond 3, right? And it could be 4, it could be 5, it could be depending on your requirements. Okay, the minimum size, I want to specify this. So maximum unavailable, I want to set it at 2. Okay, labels role, I want to say general. So these are some optional fields, right? Depending on what you require at your workplace, you might make some of them active. Okay, so now all this creation that we have here, right? The node creation and all of that will depend on these policies that we've attached, right? Remember, attach policy 1, policy 2, and policy 3 to the node row that we created. Okay, so these are other optional fields. So let's look at the next step. Okay, so we can create OpenID connection for the cluster. Okay, so to create OpenID collection for the cluster, so these are the steps. Okay, so these are the steps. So data TLS certificates, you can say techdom.eks, you can change this. So anyway, you see me putting techdom, you can modify it to your name and try to understand the flow. Okay, so this on creation of OpenID connection for the cluster. So what next can we do? Okay, I think I'm missing some things there. So there are some, that's step 9. Okay, so let's look at the next step. So we can create IAM role for the OpenID connection as well and attach some policies. Okay, just as we did for the other resources we've created. So we can have this, right? With this, we can specify what is possible, right? You can see this can, some of the expected actions will be to list all buckets and get bucket location, you see. So these are row creation and attachment of policy. You can see policy attachments. Okay, so that's that we have there. So then finally, we can create IAM role for autoscaler and attach policy to the role as well. Okay, so you can create IAM role for autoscaler, right? So you can create IAM role for autoscaler. So the same way we created roles over there is the same way we'll create these roles as well. Okay, so once we do that, we can now say we have completed the whole process. But if we want to proceed to deploying on Kubernetes and setting up for Kubernetes, there are some things we can also do, right? So let me just put that as notes. Okay, so there are some steps that can be taken, okay, to get everything going. Okay, so let me put a comment here so that it can run when we will bring it up. Okay, so let me just put comment here. Okay, so it doesn't distort our script. So let me just put the comment there. So right now we have everything where we want them to be. So what we want to do now is to run this .tf file on our server, then we can comfortably say we are done creating those resources. So now that we have this, so let me copy everything we have, right? Let me go to my instance, right? Let's create a directory, mkdir. Let's call this directory 8, right? Let's call this 8. And, right, we want to cd into that directory, cd into the directory called 8, right? So we create it and cd into it, okay? So we are in 8. So now that we are in 8, okay, so we want to vi into a file and call this file eks.tf, okay? eks.tf. So everything we've copied, we want to paste it, right? So let's save, escape, column, wq to write and quit, okay? To save and quit. Enter. So what else we want to do now? We want to initialize Terraform in our environment. Terraform init. So in it. Okay, so initialize Terraform. Let's see what we have. So once run Terraform plan, let's format first, FMT. Okay, everything is fine. So let's run our Terraform apply straight away because plan is within apply. Let's run our apply. So everything goes well. There's no mistake. Okay, so do you want to perform these actions? It wants to create, it plans to add 29, right, resources, change nothing, destroy nothing. Okay, so I want to say yes to that. So everything is getting created. You can see our internet gateway is creating, right? So you can see the subnets getting created. So we have the route table being created, the public route table. Okay, you can see the NAT gateway, right? EKS cluster is getting created, right? So the good thing is with the Terraform file, you can just go there and modify to suit your purpose, right? So it's included among the Terraform scripts that we have. I'll put a link to the video. I'll put the link in the video. So route table association. So let's even go to the browser to see what has been created. Let's start with the IAM, right? So let's see the rows that have been created. Let's see rows that have been created and see the TechDOM cluster row and the TechDOM nodes, okay, that we created. Where was it created? Short while ago. So these are the ones we just created now. So let's see. It shows that it's not being used, but I believe that will change soon once everything is created. Okay, so what else should we look at? We created VPCs, right? See, this is what we had. We had 10 subnets before. So let's refresh it, right? Let's see how many more subnets we have. We have 14 now. You can see the subnets we created. Public US East one, right? Remember the cider blocks ending in 19, 19, 19. You can see. So this is the first one, right? That's a private. So this is the next one. The other private, you can see. This is the next one, 64, public. You can see. I'm just using 19 to search for it, and this is the final one. Okay, you can see the subnets that we created. Let's see the route tables that were created and see the route tables that were created as well. Let's see. We created private and public route table, and we associated two subnets to each of them, right? We associated two subnets to each of them. Okay, you can see private East 1A, private East 1B. Okay, so those are the subnets we associated, right? Public to this, public to that, to this. Okay, so what else did we create? We created internet gateways. Okay, tech dump internet gateway, right? Internet gateway that we created. This is the default one, but this is the one we just created. We created just one internet gateway. So what else did we create? We created NAT gateway, right? So this is TechDom NAT, which we just created. Okay, so TechDom NAT, we just created it. So what else did we create? Let's see whether everything is done. Still creating the cluster. So let's see, what else did we create? If we go and check cluster now, let's check EKS. EKS. Let's see. Oh, it's creating. It shows that it's creating. This is TechDom cluster itself. It's currently being created. Right? You can see the name, TechDom cluster. So this is the IAM role. Right? So let's go and check IAM again. Let's see if anything has changed. So this is how we create, provision our infrastructure, right? Using Terraform. Okay, so what else do we have? So let's see whether it's complete. So it's still creating. It could take some time, up to 10 minutes or thereabouts. So, but while we are still at that, let's just keep exploring while it's creating for us. So what else can we search for? Let's check for instances. I don't think that will be created yet because it has not created the worker nodes, right? So we still have just one, right? Remember, we gave the instruction that we desire two worker nodes, right? Maximum of maximum of maximum of 3 and minimum of 1. So right now we just have one running instance, right? Let's see if we have an update yet. So this is still creating the cluster, right? Because it's creating them in the order we arrange them. So also, when putting together your Terraform script, let it follow a certain order because this gets done and that gets done. And wherever you need to put depends on, you also need to put it there so that you can have a clean provisioning. Okay. Okay. Cluster is still getting created. So let's see what we have. So we have nothing here at the moment because cluster is still getting created. So let's see what else can we look at. Let's see. Let's go back to VPC. Let's check VPC. Okay, let's say our elastic IPs. We created an elastic IP, right? So we could use it with our NAT gateway. So you see, take down NAT. So this is the elastic IP address, right? That we created and we put it in. You see, so that's the private IP address associated with it, but this is the public. And because we needed it for the NAT gateway, right? The NAT gateway must be associated with an elastic IP address, which was what we did. Okay. So what else did we create? Let's see. We've seen our NAT gateways. We have just one, okay, and it shows it's available. Let's see the subnets. We've seen that as well. So what else? Let's see. So it's still creating. It could take some time. Okay, so what else? Route tables. We created two, one private and one public. One to serve the two public subnets and the other to serve the two private subnets. Okay, so what else? That's our VPC there. Tech.vpc, that's what we created. Okay. So let's see. Does this say? Let's minimize it a bit. Okay, so let's see. Okay. Okay, that's nice. So I believe the cluster has been created and now the nodes are being created. Okay, so let's go back to our cluster, EKS, EKS. Let's see our cluster. You see that it will show that it has been created. Okay, take-down cluster has now been created, right? So take-down cluster has been created. And see the open ID connect provider URL. Okay, so cluster URL, we have that here. So what else do we need? Let's go check what else do we need? Let's check our Okay, let's go to EC2 now. The last time we only had one running instance. Now we have 3 running instances because these 2 new instances have been created. So these are the worker nodes that have been created using Terraform. So now we have the autoscaler creation complete. Okay, so this is still creating. So let's check our autoscaler. Autoscaler. Autoscaling. Okay. So let's see what we have there. Okay. So let's check. Where should we check? Let's check our cluster. EKS. EKS. Let's see our cluster. What was it I'm looking for? What was it I'm looking for? Okay, let's see whether the process is completed. Okay, now we can see apply complete, resources added, 29, 0 changed, and 0 destroyed. Now I'm done. I think I should delete, right? So to delete all the resources we've created, one command and say Terraform destroy. So I'm on the Terraform destroy command, right? It tells me it wants to destroy 29, right? To be destroyed. Do I want to say yes to that? Yes. Okay. So let's see. Destruction in progress. Let's just go through some of the services that we knew about. This still active. Let's check IAM. It'll take a while. Let's check IAM. We had how many rows? This still active. Has any been destroyed? Not yet with this. So let's see what's going on. Let's see what has been destroyed. So just take it one at a time. NAT gateway is still destroying. So it's saying this has been destroyed. NAT gateway destroying. Okay, internet gateway has been destroyed, right? So nodes are still destroying. So let's check out the nodes. That's EC2, EC2 instances. All right. So let's check the running instances. Oh, one has gone, one is down. So one is destroyed already. So let's refresh. Okay, one has been destroyed. Or let's even see everything at a glance. So which one did we just destroy? This one is the one that got terminated now. So let's see the other one. The other one is still running. until everything is destroyed. This could take a little while to finish destroying because we specified minimum until the autoscaler goes down. I think this one will keep maintaining 1 because we specified that we needed minimum of 1 node, right? So until the autoscaler goes down, so this will remain. So let's see what more we have destroyed. So still destroying. Okay, so cluster destroying. So let's check the cluster, EKS, still destroying. Still shows active. It could take a while, but let's see other services. I am. Okay. So the rows are still 14. So there was something, okay, the VPC, okay. I think something got destroyed the other time. I think the NAT has been destroyed from what we saw the other time. NAT gateway, okay, deleted. Okay, the NAT gateway has been destroyed. Let's see the elastic IP. Oh, it's gone, right? The internet gateway. Okay, the internet gateway 2 is gone. The internet gateway we created was TechDom IGW. So that one is gone. Let's say the route tables. The route table we created too. I don't see them again. The public and private, they are gone. So let's see the subnets. Okay, the subnets are still there, right? TechDom VPC. So the VPCs too. I still have the VPC here, okay? So it's just going to take a little while for destruction to be completed. You know, we have 29 resources that were created, and they really took time to get created. So they will also take some time to get destroyed. So let's wait a while and see what we get out of it. Let's just destroying. Okay, I think okay, so let me compile this, copy this, put in there, so I can share this. Okay, so let's see what we have. So let's see the progress we've made with the destructions. So this one should still be up. So what else do we need to take down? Let's see, EKS. I believe that will still be up as well. The cluster. It's going to be one of the last things to go down. Right, so what else? Let's see. Okay, I think the second instance is down as well. So we have just the Terraform server. So the two nodes that were created, this and this, have been terminated, okay, by Terraform. Okay, so they've been terminated by Terraform. So what else do we want to look at? Okay, okay, takedown node has been destroyed. So the cluster is being destroyed. So I am row, okay, I think some rows are down. So let's confirm that. Okay, so destruction is complete. 29 destroyed. So everything should have gone down now. So let's refresh this. Take down VPC. You should be out of the way. Okay, that's gone. So let's check the IAM rows, right? Remember we had 14. So, and we created, I think, 4 of them. So we should have 10 when we go back there now. IAM. Okay. So, 12 rows. So let's see the rows we have. Okay. Those other rows are gone. So what else? So everything is gone. So with this, we come to an end of this session. So see you in another session.